Okay, this is a review of nomenclature for your exam. Remember, nomenclature, the way I treat it, is in 5 parts. The first part is simple binary. Simple binary is essentially a metal and a non-metal. 2, metal and a non-metal. Sodium chloride, binary. Calcium bromide, binary. It's going to be groups 1, 2, 13, 14, and those are positive, those are the metals, and then, or in that case, a non-metal, and then 15, 16, 17. Why do I say group 14? Well, carbon could be +4, and silicon could also be +4, and that's going to be carbon disulfide, or carbon sulfide, but you're using the Greek prefix system to name it, but that's okay. It's commonly known as carbon disulfide, very, very stinky liquid. And then there's silicon dioxide, and you're using the Greek prefix system to name that as well. But I just want you to see that those are a little gray area with binary, okay? Usually with binary, the hallmark is the name of the metal, calcium, the name of the non-metal, bromine. The anion gets the suffix IDE. Okay, this is neutral. This is +2, that's the cation, -1, that's the anion IDE, and it's a neutral particle. Usually covalent bonding, usually ionic bonding to some extent, or very polar covalent. And that's going to be a neutral particle. Okay. Calcium bromide, the name of the metal and then the name of the non-metal with the ending IDE. Okay, so relative to the electron configurations of binary, the 1, 2, 13, 14 will give up electrons, and then the 15, 16, 17 will take electrons. So this becomes a configuration 1, 2, 13, and 14 like the preceding noble gas. And this will be like the succeeding noble gas. So for instance, calcium will be like argon, and bromine will be like krypton in terms of the noble gases. These are giving up 4 s2 electrons, and then you're ending up with a valence shell 3s2, 3p6, and this is taking on 1 electron, and that's going from 4p5 to 4p6 like krypton. Okay, now, so, binary, simple binary. Simple ternary is really, it's the same rules except ternary, meaning 3 or more. And what gives it that extra atom? Well, it's the polyatomic ions. So it's the same as binary. All metals have 1 oxidation state. However, you can have 1, 2, 13, and then you have that attached to a polyatomic ion. I'll explain in a second. And you have no suffix, just the name of the polyatomic ion, or you can have a polyatomic ion and you have that attached to a polyatomic ion, no suffix, or you have a polyatomic ion and group 15, 16, 17 with the suffix IDE. Let me explain. Let me erase some of this here, okay? And I'll give you some quick examples. Remember, you're using polyatomic ions, and the polyatomic ions are on your polyatomic ion sheet, not on the periodic table. Many of you look for the polyatomic ion on the periodic table, they're not there. Okay, so for instance, 1, 2, 13. So let's say aluminum plus 3 and sulfate minus 2. So that's the polyatomic ion. So it's going to be aluminum and then sulfate. Remember, you need parentheses if indicating the presence of more than one of these polyatomic ions. So this is 3 of this and 2 of this. When you see 3 and 2, think the least common multiple of 6. So this would be 2 of these would be plus 6, and 3 of these would be minus 6, and that would be aluminum sulfate. So that's like example 1. Tertiary, 1, 2, 3 different atoms. Okay, next. 2 polyatomic ions, no suffix. For instance, the most common positive one, ammonium, and let's be simple, ammonium nitrate. Plus 1, minus 1. Ammonium nitrate. Plus 1, ammonium, minus 1 nitrate. Ammonium phosphate. Ammonium phosphate. Notice, no suffix. Ammonium phosphate. So that's the second type, 2 polyatomic ions. Next, polyatomic ion and 15, 16, 17 with the suffix IDE. So you have ammonium chloride, that's group 17, plus 1, minus 1, ammonium chloride. Ammonium sulfide, okay? So you have 3 types of ternary, simple ternary, same as the binary. All metals have 1 oxidation state. Like I did with the example, aluminum. Aluminum is always plus 3. It could be calcium, it could be sodium, it could be barium, whatever the case may be. Okay, so that's it. I'm going to do nomenclature in 3 quick parts. That is binary and ternary. Now remember, the rules for binary and ternary, simple binary, simple ternary, are also used with the Roman and Greek system and also acids. Same, you don't break any rules, but you have additional rules with Roman, Greek, and acid nomenclature.